Hello, my name is Rob Tomenchok, and I'm an engineer with Allied Electronics here in Bristol, Pennsylvania. And I'd like to talk to you a little bit about STEM. So, to begin, my journey in STEM started when I was just a little kid in the 1960s. It was the heyday of NASA. It was a time when we were transitioning from vacuum tubes to transistors, and then transistors to integrated circuits. It was during the Cold War, and so there was a lot of military equipment and hardware, and a lot of militarism. And I can always remember the times that I would see scientists from RCA in their white coats and their flat top haircuts and their slide rules, and I thought, boy, that's for me. And what really did it was radio. I got started into shortwave radio, and I was very fortunate to have parents that saw my passion for technology. It wasn't called STEM back then. It was just electronics and science, and they provided for me a laboratory in the basement, and my grandfather scored for me an oscilloscope. That's a device that actually plots out an electrical signal in time. And I'm just an elementary school kid with this really cool oscilloscope that most adults in the electronics hobby wouldn't have. And so throughout my career, I've always been very passionate about science and the foundations of science, the history of science. And now I develop embedded real-time code for these devices called forward controllers, which are made by Allied. And that requires software knowledge, it requires mathematics, there's electrical engineering involved, there's a little bit of mechanical engineering involved. And as of late, quite a bit of high-end mathematics because of the cryptography that's going on. The little chip cards. The chip cards are a major change in the way we do commerce, and so that is where we are now with things. That's a very good question. I think it's very important to have a deep understanding of the way things work. And in order to get that, you really need to understand physics, you need to understand chemistry, you need to understand the mathematics behind it. And the way to do that is in science class, and not just something called the I believe button. You push the I believe button. When you're in church, you push the I believe button because you can't see what's going on. You can't see, there's a big difference between, say, technology and religion. In religion, it's about faith. In science, it's about observation. And so you really want to know how things work, not just say, yes, I believe that this is going to work. Don't just learn things by rote. Get in there by repetition, by rote. Get in there and figure out what's going on, what is really happening. And the way to do that is to just keep digging. Ask why. Always ask why. Why is this happening? Not just say, the answer is 75. Well, why is the answer 75? And what can I do? How can I play around with things and make them a little bit different? Figure out the limits of things. Break things. Break things and then fix them. That's a pretty good question. That surprises people. I would say that the sophistication of our product is what surprises people. Because when I was a kid, there was no automation in gas pumps. All right, and you don't really think about it when you go up there. you go there to put fuel in your car, you don't realize the technology that's behind it. For example, I can remember when I was a little kid, and my father was working his way through college, turning wrenches and pumping gas at a Gulf gas station. And at the end of the day, you had to actually put a padlock because there was still fuel in the hose, and there was absolutely nothing other than 110 volts going out to the pump. Now we have essentially an Ethernet connection, and in some cases you can actually get internet connections to a gas pump, just like the Internet of Things. Well, that's in the forecourt, which is where these devices, they live in what's called a forecourt. So it's the level of technology and sophistication in the controller is what surprises people, the amount of things that it does. Yes, absolutely. Everything is going to coding. There was a time when you would draw a schematic if you wanted to design an oscillator. An oscillator is something that oscillates back and forth, makes a tone. And that tone can be from deep all the way up to microwave level. You would go through the mathematics and design the circuit. And an oscillator is basically it's an amplifier with a bunch of feedback. It just, have you ever been too close to a microphone and a speaker? You've become an oscillator. Well, the design of that kind of equipment and the mathematical modeling of it is no longer done on paper. You still can, but everything now is done by computer-aided computer-aided design, computer-aided manufacturing. So yes, it's very important to be able to communicate with the computer because that's doing heavy lifting. But at the same time, you still need to know what the computer's going to be doing. Mm-hmm. But it's the tool. So that's a long-winded way of saying yes. Coding is very important, and again, play with it. Make it do something. You can make computers do backflips now. Get in there and it's okay to break things. Because you will. You're not going to get it right the first time. You're going to say, why did it do that? It's because you told it to do something. It's why it did it. So yes, absolutely. Coding. I'm a big fan of the C programming language, C++, C Sharp. Mm-hmm. There are some relatively simple languages, or less intense languages. Python is one of them. And there are some others that are out there kicking around. But start with Python. It's a simple language. I'm not a big fan because I like a little more structure, mm-hmm. like things a little more explicit. Python's a little messy, but get in there and play with Python. Yes, and that is learn something new every day. Treat yourself. It's a treat to learn something new. And I've always considered mathematics, science, the physical sciences to be that's kind of the main course, and then the dessert course is history. Mm. All right, read about people like Thomas Edison, mm-hmm. Nikola Tesla, Edwin Armstrong. There's a guy named Philo Farnsworth. Learn about Philo Farnsworth. Funny little name.
Yeah.
But learn about the people that built the technology.